power rule on something like this? No, because I have division. You have to have the terms only added and subtracted. So we have to get algebraically creative. Cody, take your stuff, sit there. Okay, I can't do power rule on this. As tempting as it is, because it looks nice and sweet and pretty, move. So I have to somehow get rid of the division. So what's creative algebra we know that we can get rid of the division? Can't.
Could you multiply by the p 2/3?
Close. Colin said, could I multiply by the p to the 2/3? He's on the right track. But I have to get it to come up to the top. Which, when it comes up, what does it become? When you bring it up, does it flip the fraction over?
No, it makes it negative.
Yeah, it just makes it a negative exponent. So it just comes up as p to the negative 2/3. Okay. Now, you still can't do power rule yet because this is multiplication. So now you have to distribute it. And no, you have to be able to add fractions. Oh, no. Okay, because when I distribute that p to the negative 2/3 in there, I have to add powers. So what's 4 plus negative 2/3? 12/3 plus negative 2/3 is indeed 10/3. Okay, so then 2 is how many thirds? That's 6/3. Adding negative 2/3 will make it 4/3. And then I'll have 9p to the negative 2/3. Did I change that sign? No, not the one in front. Nope. And technically my dp is still sitting back there because I haven't actually successfully done the integration yet. I got to get bigger. Alright, so now you have it in a form where you can do the power rule. Every term is added and subtracted. So, now it's integration. You're increasing your powers by 1. So 10/3 will become 13/3. I don't want to divide by 13/3, so I'm going to multiply by 3/13. And once again, we'll come back and clean it up in a minute. Okay, 2p to the what when I add 1 to the power? 4/3 plus 3/3 would be 7/3, so I'm going to times by 3/7. 9p to the 1/3 times by 3 then. Anything else? Plus c. And then go back and multiply your numbers together. We really got, what, 9/13? And then it's minus 6/7, p to the 7/3. That would be plus 27 p to the 1/3. Let's see. So, if you're careful, the mistake I see here is usually basic algebra and arithmetic. I have lots of people who will bring that p to the 2/3 up and forget to distribute it. And then adding 1 to the power with all those fractions in it. Yeah. Subtract where? No, if I add 1 to 10/3, adding 1 is 3/3, so 10/3 plus 3/3 is 13/3. Okay. So actually on every one of these I was adding 3/3. And I'm not going to give you something horrible with terrible, thirds, halves, fourths, something nice and reasonable. I'm not going to give you 67ths or something.
Well, at least we know when
Yeah. They're not that bad, just takes a little practice. I won't lie to you. I can do all derivatives, every derivative probably there is with, I don't know, 25, 30 rules. Going backwards with integration is way more difficult. I have a book with 760 some different rules of integration. Going backwards is far, far harder.
That's because we don't deal with the missing three.
No, we are learning this rule this year, that's it.
Right now, integral to.
They've learned, I don't know, somewhere between 20 and 30 methods. They've learned quite a few methods now, but nowhere we begin to scrape all those different variations of it. Okay, what you all just did here, Luke, this might be an external question. Everything you've just done is what's known as an indefinite integral. Okay, what is indefinite about it? The C. We don't have a definite exact value. We don't know what C is. Okay, we are now about to do what's called a definite integral. Our answer is going to be a number.
So indefinite results in.
Indefinite integrals result in an expression with plus C.
So would it be like I'm just missing constant?
It is the fact that you're missing a constant. There's actually more to it than that, but I'm going to get to. It's partially the fact that you don't know the value of the constant, but it's also it's an expression in x's. When we do definite integrals, our answer is going to be a number. It has a value. We're going to convert this into a number here.
So definite is what exactly, a number?
The answer to a definite integral is a number. What it represents in terms of a graph, I'm still not there yet. I'm getting there. But I'm not there yet. Can I switch screens?
Yeah.
Red. Some different. Okay. You may. You think it will help. It maybe get warm enough so it may not help.
I wrote plus B in big, like, scratched out stuff at the top of my paper, but then Mrs. Meyer, it looked like just C plus. The connotation is C plus on the top of my paper, and now I feel like it's very like.
Okay. So, definite integrals, on the other hand,
Why do we have numbers on the one?
that's what makes it a definite integral.
Is that like number correct? So you use the prime symbol to signify,
The prime symbol can be one of the ways to indicate derivative. Yes. Yeah. There's so many ways to indicate derivative, it's kind of crazy. Alright, so, yes, you noticed what's different here?
There's numbers by RS.
Yeah. Those are called the limits of integration. Does that excite you?
thrilled.
Okay. I'm going to teach you how to do a definite integral, and maybe I'm going to get to the what's this mean? Why would we throw those crazy numbers on there? And when we get this number answer, what's it mean? But, okay, when you actually work a definite integral, you do the exact same thing we just did. You do the power rule like we were just doing. You save the numbers. We do something with the numbers at the very end. The first thing you have to do is simply get the thing integrated. So, how do I get it converted? This is the derivative. How do I get it back to the original function? Integrals do what to power? Increases. So, increase your power. 2x squared over 2 minus 5x. And I technically should add plus c. Okay, now, I can't keep writing the integral sign out front because I actually have done the integration. So what they do to say, hey, dude, I still have these numbers I'm supposed to do something with, they draw a line in the back and put the negative 1 to 2. That's read from bottom to top. Smaller number is always on the bottom. Bigger number is always on the top. So that's from negative 1 to 2. Okay. The process then, for working this out, I need to sub those numbers into this formula. And what you do is you sub the top number in, you subtract, and you sub the bottom number in.
Can you cross off those two?
Yes, I can cancel the 2's. You are correct. That would be a good thing to do. So you're literally going to sub 2 in for x. What am I going to get? 4.
1A.
2 times 5 is,
Oh,
yeah,
my bad.
plus C at the moment. Okay, then, here's the biggie, you subtract, you write a parenthesis because the subtraction has to carry through, and you go put the other number in, put the bottom number in. So, 1, that's going to be 1, 1 plus 5 plus C, and then you add it all up. Okay, what happens when you distribute the negative? Negative 1, negative 5, negative C. What happens to the C's? The C's cancel out. In fact, the C's are going to cancel out every single time. You do not have to do the C's when you are doing definite intervals. The C's will always cancel.
And they don't cancel if you get it wrong.
Yeah. But you don't even have to write them. Yeah. You don't have you don't have to write the C if they actually have limits. If it's,
Negative 12, Mrs. Meyer.
oh, thank you. And if you add it up, I got negative 12.
That's what I'm gonna go with.
Negative 6. Yeah, I'm going to buy negative 12 too. Okay. So this particular one comes out to a value of negative 12. I really will get to what that means here. That's all you do on those.
That's fine. Take out our task. Make that our whole task. Really, really good.
Okay. We're going to come back and do another one of those in a moment, but I want to get to the what on earth does this mean numerically? Why am I doing this, and why am I slapping numbers on here? But before I do that, I need you all to do one other little problem for me real quick. Okay. Just to double check we've got it, I want you to do this very difficult problem. I want you to integrate from 1 to 4 the quantity x plus 1. Okay. You all see if you can do it real quick while I find my website I need. X plus 1.
Okay.
So just nice basic x plus 1. X plus 1, the limits were from 1 to 4. That's all you're doing.
That tells me that the calculator could probably do it for us.
Something tells me you're wrong.
The ones the calc students have.
So it's 4 to 1, 18. Yeah.
So you're gonna have,
Right, 18 is your answer?
no, that's not right, it's, 11 and a half, right?
Yeah, 11. I love dissension. Oh, come on, dude. You're going to load my page.
No, 10 and a half, right, yeah.
Oh, I know what I did wrong.
Oh, yes, I know. Get an update.
I don't want to update right now. It takes too long. I said later once before. Now you're loading. Okay.
So right, 10 and a half, Mrs. Meyer.
That sounds better.
I forgot to address that.
Okay. That'll make my point here in a moment.
Same.
All right.
Same.
So, I've heard multiple answers. Do we have any consensus? I got
That's what I said, yeah, 10 and a half.
10.5? So, when you added 1 to the power divided by the power, you got x squared over 2 plus 1x. Did you write your c?
Yes.
You can if you want to, but you don't have to because they're going to cancel.
Did you see where the points go?
Nope. Actually, it'll get in your way. You need to learn to not write it on these. less junk in your way. Okay, how do you know which number to put in first? That's sometimes an issue. So it's top number in first. So that would be 16 over 2, or 8, plus 4. And then the other common mistake is when you subtract a parenthesis. So that's going to be 1/2 plus 1. And then you need to change your sign. Me personally, when I do this, I add up all the whole numbers and then I do the fractions at the end. So 12 minus 1 would be 11, and 11 minus 1/2 is 10 1/2. Okay, so hold that thought for a few moments. All right. Now I want to take you to where they actually went with this, why we are,
Explain